In this chapter, we're going to talk about multi-threading. So one of the most powerful features of Java is its built-in support for multi-threading. And that is the concurrent running of multiple tasks, meaning we have more than one thing running at the same time. There's a couple ways that this can be done. So each one of these tasks will run as a thread, and we're going to see examples of this coming up. They'll run as a thread, and one of the ideas that we could use is that each one of these threads can run, if we have a computer that has multiple CPUs, some kind of quad core processor has 4 CPUs, we could have a thread that runs on one CPU, another thread that runs on a second CPU, and even another thread that runs on a third CPU. And these tasks could run at the same time, rather than waiting and running one after the other. The other way threads can be used is that they're sharing a single CPU. So you can have one thread running, and it runs for a little bit, but the thing about this is a lot of our tasks, when they run, there's still a bunch of wasted CPU time while they're running. So we could have a little piece of thread 1 that runs on a CPU, and then thread 2 can run for a little while. Thread 3 could run for a little while. It could go back to thread 1 for more time. And all those wasted CPU cycles that happens while these tasks are running can get filled in, and 3 of our processes can run at the same time, but they're kind of time sharing on the same CPU. So let's take a look at an example. I made this little example similar to what you can find in your book. And we have this class called print character, print char. Basically, it has 2 fields. One field where we can specify a character that we want to print, and another field that says how many times we want that character to print. Here's a constructor. When the print char object is made, we can specify the character to print and the number of times we want it to print, and they're going to get stored in those 2 fields. And then we have this method called run. And when we call the run method, it runs a loop that runs from 0 up to the number of times that we specified, and it just prints out whatever character we told it. So it's got one method in it called run. It's got a constructor, and it's got a couple private fields. Very simple task. Hey, repeat this character 100 times or 50 times or however many times we tell it to. I've created a demo, and I want to take this line out for now and this line out for now. So here is the driver program. It's going to create 2 versions of this. It's going to have print A, and print A says we want to print the character A 100 times. I made another print char object that prints B, and when I created it, I said I want to print the character B 100 times. And when we run it, that's what happens. A prints 100 times. So it calls that run method right here. A gets printed 100 times. When that method is done running, it runs print B, and that runs and prints B 100 times. I also made a print num class. It's very similar, except this one, print num, just stores how many times do we want to print the numbers from 1 to what. And it has a run method, and it counts from 1 to whatever. Okay, so if I tell it 100, it'll print the numbers from 1 to 100 out. Let's go back to our demo and add that back in. And the same thing is going to happen here. We're calling the run methods. For each of these objects, we have a print number object we've added in there now. So we print A 100 times, then it prints B 100 times, and then it prints the numbers from 1 to 100. And these things are happening sequentially. The first object does its run method, then the second object does its run method, then the third object does its run method. Now, when I created print number, though, I actually created it a slightly different way. So let's go look at the print number class. And we can notice up here that print number actually implements an interface called runnable. Okay, and the runnable interface basically says that if you implement it, you have to have this run method. So it's not that much different from our print char method, other than it implements runnable. And we added some language here that says this is overriding the run method that comes from the runnable interface. Runnable interface says there must be a run method. So let's go back to our print char class and add the things. So we have the run method already. I made that. I conveniently named it run. I could have called it anything I wanted, but I called it run because I knew I was going to be adding the runnable interface. So print char, let's specify that it implements runnable. Okay. So the runnable interface is required when we want to do multi-threading. And basically it just says that we have to have a run method, which we already had. Now I'm getting a little message here that says let's add override annotation, so we can do that, and it just adds this so that we know the run method is actually overriding the run that's specified in the runnable interface. And we've talked about interfaces before, so that shouldn't be new. Doesn't really change anything, because in my driver class I am still creating objects from each one of these and then calling their run methods sequentially right after each other. And it doesn't change anything. But now we're going to do something to create threads instead. So we're going to modify our code. So instead of creating these objects as print char objects or print num objects, I am going to redefine them as runnable. Okay, so we're going to make our references to them be of type runnable. Nothing else has changed. We still created the object from the print char class, another object from the print char class, another object from the print number class. Okay, we just made their references of type runnable instead of their own class types. We will no longer be calling them using the run function anymore. So let's get rid of that. We're not going to call the run method anymore on these. What we're going to do is from each one of these runnable objects, we're going to create a thread. So I'm going to say thread, I'm going to say thread1 equals new. It's a new thread. And for the thread class, we have to specify what object we want to run. And in this case, we're going to run print A in thread1. So this creates a thread from this runnable object. This runnable object print A now gets created and used inside this thread. And we're going to do the same thing. Let me copy this. Left thumbs today. 3 times, and this will be thread 2. And this one will be thread 3. This will use the print B object. And this one will use the print num object. Okay, so now we have 3 threads set up that take these 3 runnable objects and specified that they're going to be used in these 3 individual threads. Now, we don't call the run method anymore. We tell thread1, we call its .start method. Okay, and this tells, hey, thread run that's using this print A object, go ahead and start. Thread 2 that's using the print B object, go ahead and start. Okay. And when we tell it to start, it runs the run method for our thread. So we're not calling the run method directly anymore. We're putting the object in a thread and then calling .start on that thread. And .start will run the run method that they have to have because they're all implementing the runnable interface. So thread 3 .start. So now we have threads, and these threads will all run concurrently, or they'll share time on the processor depending on what computer you're using, but they won't execute one after the other. They'll execute all at the same time. Now, there can be some variance in this, so I'm going to run it and let's see what happens. Looks like my 100 A's, well, I didn't get all the A's printed out. I printed out a bunch of A's. Then it did some B's for a while. Then it went back and did some A's for a while. Then it did some more B's for a while. So they're all kind of running at the same time. But it does look like my A's and B's finished before my numbers ever started. And that's because I'm working on a pretty fast computer. So let's see if we can make this a little bit more mixed up. I'm going to ask each one of these to run 500 times. And let's try it again. And now you can see we have some B's happening. A lot of B's. Then a whole bunch of A's. Then finally some 1, 2, 3s. We go back to some A's. We get a 4 in there. We get some more A's. And then I think by then our A's and B's are done. If I run it again, I get slightly different results. This time it started with some A's and then it did some B's and it did a couple more A's. Here we got some 4s and 5s coming in, some more A's, a 6. So all these threads are running at the same time, sharing time on the processor. But it looks like A and B tend to get done a little bit before the numbers ever quite get started. So the A and B that are both using print char, they seem to run pretty fast. Let's try to change something. Let's, in our print char, let's tell it to yield, and we'll talk about more about what yield does to see if we can slow this down. We're going to call it thread.yield. If I can type. And if I can spell, let's try thread.yield. All right, we're going to call thread.yield in our print char run method. And we'll talk about what that does, but basically that says, hey, give these other guys some time to run and see what happens here. And we get a little bit better mix, but I don't think it's actually great. So the A and B printing does yield a little bit more often now to us. So we get the A's, we get some B's. Ultimately, down here, we get some more numbers mixed in early. And we'll talk about what that yield does in an upcoming video. And you can see our numbers are printing. We get some more A's and B's. A's and B's don't finish quite as quickly now because we tell them to yield while they're running. After every iteration that they run, we're telling them to yield a little bit to give those number ones a little bit more time to add. So you can see A and B doesn't always finish before. So when you do this on your computer, and I do encourage you to try it, go ahead and play around with some of these things. Increase the number of times the A and B are getting printed if you don't see it actually getting to share time. Increase that number, or have your, if the print chars are finishing earlier, go ahead and play with the yield, and you'll see that you can manipulate them a little bit The faster your computer is, the more likely some of these threads will just instantly execute and get done. So we can slow it down a little bit with things like yield, or we can increase the number of times things are executing, which gives us more opportunity to see them sharing time on those processors. And here we get quite a bit better mix. I just increased, we're going to 1,000 on everything now. But ultimately, it seems like the A's and B's in this case do get done a little bit faster, and then we finish up with the numbers. So play around with that on your computer. Again, you'll probably see it mix better if your computer is slower. I happen to be working on a pretty fast computer, so I had to do some things to actually see the threads all running at the same time. And we can see that going on in here quite a bit.